Welcome to my second installment of why calculus teachers are obsessed with conjugates when they come to teach um, complex numbers. So if we have a look at this, really first quick question, what's going to happen when we add these two conjugates of each other? So clearly we're going to add the real parts together. So 3 plus 3 is 6, and plus 7i plus minus 7i is going to be 0. So we get a real number here. The imaginary parts are cancelling out. We've added two complex numbers. We've got a real solution when we add them. Okay, when we get to multiplying these two conjugates, what's going to happen there? Okay, so by the way, when I multiply here, I no longer use FOIL, I use philo. And so for philo, what are we going to do? We're going to go first times first, which is 3 times 3. Last times last is going to give me, what is it? Plus 7i times minus 7i. Okay, and then I'm going to have, what am I going to have? I need inner, so plus 3 times 7i, and then outer, plus, but it's minus, so minus 3 times, well, plus, let's say plus 3 times minus 7i, but obviously here, these two are going to cancel each other out, aren't they? So, can forget about that. Okay, what am I going to have here? I'm going to have 9. Now I've got minus times a positive, but I've also got I times I. So actually, let's write it. Minus 49. Minus 49i squared, but then the I squared turns into another negative, so I'm going to end up with 9 plus 49. Oh, hang on, I'm getting another real number here. So when I add conjugates, I'm getting real numbers. When I multiply conjugates, I'm getting real numbers. Now, I can leave it with you to go through and prove that for numbers like a plus bi and its conjugate, a minus bi. You can add those together in your own time. Double check that you do in fact get 2a. I think we will actually show you exactly how to multiply those. So let's actually just do that real quick so that we can see, will it always actually work? So a plus bi times a minus bi, will we always get a real number? Let's have a look. So we're going to have a squared. Let's do this. So minus b squared I squared when we multiply those two together, and then we go plus abi minus abi, and of course we're getting a squared plus b squared, and in fact that's a shortcut that you can in fact use. So if I say I've got some some number here and I want 10 minus let's go with 7i, then in fact you can actually just quickly whip in, take the 10. So if I say I want to work out what z times the conjugate of z is, I'm going to go 10 squared, following the a squared there, minus, plus, the b squared there. Now remember that the conjugate of this is going to be the plus 7i. and the plus times the minus will give us the, well, basically this formula tells us that we don't need to worry about the signs, okay? You can have a wee think about through why that is. So plus 49, so this is actually a wee shortcut that we can do without all that working that we did up here. Of course, you can do it this way and you should get the right answer, hopefully, provided you know what you're actually doing. Cool. So that's the second video in my wee series. We're going to use this information on the next video, so I look forward to seeing you there. Okay, thank you.